Good afternoon. I wanted to spend the next hour or so talking to you about a subject that hopefully is one we share in common, and that is gaining insight from data, trying to make sense of an ever-increasing amount, volume, and complexity of data that we all seem to be exposed to. I also was going to start with some acknowledgments as well, and I wanted to thank the National Library of New Zealand for sponsoring my trip out here, and obviously also the National Digital Forum for inviting me to talk and letting me attend the conference, and obviously to everyone that works at Te Papa itself for providing such a fabulous venue. So thank you to all of those. And obviously thank you for hanging around at the end of the day. I know I'm keeping you between your beer at the networking event, so I will try not to run over. I thought I would start by just giving a brief introduction to Microsoft Research to put in context where I work within the organization, because it's a big company. It was founded in 91, and really you can think of it very much like a computer science faculty of a university, just perhaps bigger, and obviously that is able to be funded through the corporation itself. So we have labs around the world. As was mentioned, I work in the one on the west coast of the United States in Redmond, Washington. And we support basic research, basic grassroots research in virtually every field of computer science. There have been major breakthroughs in our labs in things like artificial intelligence, something we're hearing more and more about now, security, human-computer interaction, which is something I'm particularly interested in, and more. And we have active collaborations with the academic community across the world. To date, I think we've published more than 10,000 peer-reviewed academic papers. So it's an interesting part of the company to work for, and there's a link there if anyone's interested in more information. What about me? So I'm part of a very small part of Microsoft Research. I'm in a team of two. My team is called NextViz. You have to apologize. I have to apologize for the Americanized spelling, but when in Rome. So we are focused on a number of things related to data, and I wanted to give you a little bit of a potted history of some of the things that have come out of the group I've worked with. Now, actually, this goes back to my supervisor's work before he even joined Microsoft, but he was involved in producing what was one of the first interactive CD-ROMs back in 1995 called A Passion for Art, that was a collection of Renoir, Cézanne, Matisse, and Dr. Barnes's collection. And it was a company that was founded by Bill Gates, and he was obviously still working for Microsoft at the time. And it was an interesting way of bringing some of this art in a curated fashion onto an early form of interactive digital media. It introduced this notion, at least to my supervisor and me subsequently, of tours, these curated tours where it's not just about showing the content, but it's taking people through stories, effectively, of pieces of useful information that aren't just the paintings themselves. Shortly after that, Bill G bought the Codex Leicester in 1994, I think for the princely sum of about $31 million. And one of the things that everyone was afraid of, that would get locked away in a private collection, but quite the opposite happened, and he invested a huge amount of time in trying to bring this experience online to be shared with other people. And here's just a screenshot from another CD-ROM that was published a couple of years later, where you're looking at one of the pages from the Codex Leicester, and you're using what they called the code scope to hold over a section of that manuscript. And clearly, most of us can just enjoy looking at the beauty of the manuscript, but few of us can read mirrored Italian. So one of the nice things about technology here is that we could match the language. You could just mirror the Italian if you've read Italian. If not, you could have the transcription as well, and you could drag this code scope across the page and get some information that you would otherwise miss, and you got a very different experience because of that. So, my supervisor then joined Microsoft Research, and one of the things he worked on first was a project called Worldwide Telescope. Worldwide Telescope, or WWT, was an attempt to try and visualize the universe, it's the easiest way to say it, by working with a vast amount of astronomical data that was starting to be collected on databases spread around the world. At the time, very large databases were not the norm, and this was a project to try and work with terapixel images and be able to gather a lot of data in a single place to allow people to explore the night sky and the solar system and link off to various pieces of interesting data along the way. It further developed this notion of tours, and it allowed the community to create tours of the solar system or portions of the universe in a way that could be shared with others. So it was a really good educational resource, and I'd highly recommend using it. It's now been open sourced and is free to use and modify for everyone. The next project that came out of my team was something that was codenamed PowerMap, but is now part of Microsoft Excel. And this was a way of working with geodata. At the time, people didn't really have a good way of doing that if they just lived in Microsoft Excel. There wasn't an easy way of looking at geospatial data. And this add-in, as it was then, was a way of combining some of the mapping information from Bing Maps, some of the learnings we'd made in Worldwide Telescope from building an Earth model that could layer data on top of it, and this notion of tours, that you could build a story by looking at different facets of the data and share that story with other people. So that's a little bit of background of what came before the project that I want to share a little bit more about with you today. And really it comes back to interpreting data. How do you interpret data? And this was touched on in one of the Lightning talks. Here's some data, and this is a tabular data set. It's actually quite a famous data set. Some of you might recognize it. So there's 4 series here, 1 through 4, each with an X and Y. And I want to understand something about this set of data. It doesn't really matter where it came from. So one way of doing that is to use statistics. I could start analyzing those numbers statistically. The only trouble is if you do that, all 4 of those series come out with exactly the same results. The means are the same, the variances are the same, the correlations are the same, the linear regression line is the same. So from a statistical analysis, at least this statistical analysis, those data series are the same. What about if we visualize it? Let's do a visual analysis of that data. Let's just plot them. Now, those look very, very different to me. Statistically, they're identical with those analyses that we ran, but I can instantly see at the top left, I've got fairly correlated scattering of values. The one below that on the bottom left, I can see quite clearly there's a very, very strong correlated series of lines and probably an outlier, a piece of dirty data. Top right, I can see there's an interesting curve going on. And the bottom right, again, everything is of a similar value, at least on one axis, and again, there is another outlier. So you can learn a tremendous amount just by looking at it for a split second if you visualize the data. So visualization of data is incredibly important. We're visual people. A huge proportion of our brains is dedicated to processing visual images, and we're pretty good at it. Now, it's not to say that computers can't do some of this job as well, but we're actually very, very good at doing it too, and we can complement computers in interesting ways. So can you see all the 3s there? I can't, but I can now. And this is another interesting aspect of one term that was coined pre-attentive processing by Christopher Healy a few years ago. This was the notion of the fact our brain can spot things that look different from other things. Before, the 3s were just part of a noise, but I've made them a different color, and I can instantly see those, and I can count them pretty quickly now, far quicker than before. So I can spot those in a way that I couldn't see easily before. And you can do the same thing with shape and size, and a few things work. Independently, they work very well. You start mixing them up, so you've got different shapes and colors and sizes, and it becomes a little bit harder. But that gives you an example of how you can help people find patterns. And there's another notion here around what I'll call quantitative or qualitative visualization. On the left, we're looking at a false color image of the US, colored by annual precipitation. And the scale is not really important. What you can't really do is get a sense of how much more rain there is, at least in quantitative fashion on the left. You can just see that there is more somewhere and there is less somewhere else. If you look at the same data on the right, that was actually a power map visualization, what we've done here is controlled the height of these bars by using the same values. And we've still colored it as well. And you can actually see very, very clearly the quantitative differences between rainfall in the US. And actually, when we showed that to some people, they actually didn't believe it, but the data somewhat speaks for itself. Now, one of the things that I'm particularly interested in is three-dimensional data visualization. This is something that's had a bit of a traditional bad rap in data science and data visualization circles. And there are some challenges. It's not without reason. One of the typical ones is occlusion. If you're looking at a 3D scene, there's going to be stuff that's hidden potentially by stuff that's in the front of the scene, and that's bad. There's also going to be perspective involved. There's going to be stuff that you can't easily compare because it's actually smaller because it's further away, for example. Then there's this notion of as soon as you take a 3D scene and you flatten it to a static image, you lose part of that. And that's one of the problems of sharing these things in, for example, printed material. It's really, really hard to do in an effective manner. But there are opportunities as well. And we can spot patterns in 3D that we wouldn't otherwise see if we looked at a slice through 2 dimensions. There's anecdotal evidence that we have better spatial memory for things that we see in 3D. That's the way our brains learn. We learn to recognize the world and remember the world in 3D. So that can help with spatial memory, it seems. And there's an option with technology now of representing these things dynamically, using animation, using 3D vision, so that we don't just look at a flat image. So what I wanted to do is demonstrate a prototype of a visualization tool that we've been working on for a little while to show you how this could change the way we start working with data. Now, this is a tool that works with spreadsheet data, it works with Excel data. This is not really targeting the data scientists of the world, but the people that are using Excel day to day. Okay. So I'm going to start with a data set that shows a couple of things and then move on to something a little bit more contextual. So here, all I've done is loaded a spreadsheet. It's actually this spreadsheet here. And as was pointed out earlier, this really is very difficult to interpret. So I've just loaded the same spreadsheet into this tool. And what I'm doing is representing each of those blocks, each of those rows, rather, as blocks on the screen. You can see these little cubes, actually, if I zoom into those, they're little cubes. And all I'm doing is laying those cubes out and coloring them and sizing them according to the columns in my spreadsheet. So it's a very, very simple way of, in this case, looking at a mapping of geography. Because it's geographic data, I've added a map, but this is in no way specific to geospatial data. So this tells me, for example, where this is tornadoes in the US. This tells me where Tornado Alley is. I can see a large number of larger white cubes in the sort of mid and mid-east portion of the US. And I've colored them and sized them to emphasize the stronger tornadoes. So that's where Tornado Alley is. But it doesn't tell me anything, for example, about how many tornadoes you get in a given place. So what I'll do here is I'll just switch to a different insight, a different view of this data, and look at it in this way. So all I've done here is I've stacked the cubes on top of one another after making them the same size so that you can get effectively a histogram, a count of how many tornadoes take place in a given area. And you can see some places get significantly more than others, and you can see that there are virtually none on the western coast or the western side of the United States, which is where I live, so that's fortunate. We do get earthquakes, though. So that's a new insight. We're gradually revealing patterns in this data, and we're able to reveal them in a way that is story-like. I'm telling you a story about the insights that I found in this data. I didn't know anything about tornadoes before I looked at this data set because I grew up in the UK, and we don't get tornadoes there, but we do get them in the US. So we could add time. Time is in the spreadsheet. So here I'm looking down on the data, geographically, but here I'm looking at effectively a history. I've put time on the upward axis here. And you can see that there are clusters that are very easy to spot. There are clusters around here, and there are clusters around here. And this is really testament to our visual processing ability. We're looking at about 42,000 blocks here, and we're instantly picking out where there are clusters of large white blocks. Those are the multi-day storms that have taken place in US history. And generally, all of those clusters have entries on Wikipedia, because they were pretty significant events. And you can also see there's some gaps, some banding in the data, which suggests there's probably some periodicity going on, because it is continuous data. So sometimes visualizations of data prompts additional questions. So the question that it prompted here was, let's look at that by month of the year and see if there's a pattern. And what I'll do is I'll just expand the width of those stacks a little bit so it fits slightly better on the screen. And you can see here that I'm still drawing all of those cubes, but I've stacked them up in such a way that represents the month of the year. And in this particular case, I'm splitting them by the strength, but I don't have to, so I could take the strength off the forward axis to make a more traditional 2D graph. And so here, you can see it's quite clear that May is the big month for tornadoes in the US. And you can do the same things with time, you can do the same things with year-on-year values, and you can see that you can build up key insights into the data, which you can save as keyframes that you can then share. Okay. So I won't dwell on that particular data set. I thought I'd find something a little bit closer to home. So let's look at some data I downloaded from 2016. So this is a set of about 20,000 seismic events from 2016 up until the present day as of about last week when I pulled the data down. And you guys get a lot of earthquakes. I mean, these are not all earthquakes. Some of them are other things, which is quite interesting. But most of them, the vast majority, are earthquakes. And again, I've colored these by the magnitude, just to highlight where the big events have taken place. And I can spin through this data in interesting ways. So, for example, let me look at just spinning through by time here. So let's just pull this slider through a little time window. And you can see typically, as the year goes on, not much happens. August, big series of earthquakes just off the northern coast there, early September. Getting up to almost present day, and bang, a huge number of seismic events. And so from a temporal perspective, it's an interesting way of looking at the data. But of course, this data is three-dimensional. Earthquakes don't generally happen at the surface. They happen below the surface. So we can look at this from the perspective of data beneath the surface. Now, it might be a little bit clearer in this particular case if let me just change the color a little bit, and I'll just change the way I'm looking at this data just so that I can see through these, make them a little bit transparent. And so here you can see, interestingly, if you look at the data in this way, it's very, very clear that the fault line runs at this angle beneath the country. You can see, actually, when you look at it this way, how clear that angle is as it runs beneath the country. And that's really, really hard to do in 2 dimensions. You know, when you can walk around the data and look at it in 3D like this, you can see exactly what is going on beneath the country. And obviously, we can still pull our time control through that and look at what's going on as the year goes on. Those 2 major events there. So I'll just change that back to looking at it in a non-transparent way, change the color, and we could look at, for example, it in this way. So this is just looking at a time-based plot. And you can see those 2 big spikes for that major quake that happened sort of towards the end of August, beginning of September, and one that happened just a couple of weeks ago. So what I'm doing is just stacking it by year here. And let's look at it this way. So this is looking at the magnitude profile. So generally, I mean, the story's not so bad when you look at it this way. I mean, 1.4s, 2.2s, yeah, but obviously some very, very severe ones, 2 over 6.8 in the last year, or less than a whole year. And interestingly, you can look at it by depth as well, and start making interesting assumptions there. There's some interesting data actually online about these seismic events. So just look at it from this way. So these were the event types that were recorded by the data source. And I'm particularly worried about this guy here, which claimed to be a nuclear explosion that took place. Now, I did some searching and I couldn't find any evidence of where that took place. And if I go back to a view of the country, you'll see where that label sits. I mean, it was pretty much right in the middle of the North Island and was supposed to have happened on the 18th of April of this year. Now, if anyone would like to own up to letting off a nuclear explosion, let me know. But I think that's probably an example of where the interpretation of a seismic event has probably been misread. But anyway, who knows what happened. One other thing that I was interested in is, not having been to New Zealand for a little while, I was interested in understanding a little bit about what my flight would look like when I came into Wellington the other day. So I found someone that had an ADS-B transceiver that was logging plane positions, which is quite interesting because that's three-dimensional data. So here I can look at a view of 24 hours of activity of plane flights over both islands, or the tip of the South and the North Islands. So, and unfortunately, the ADS-B receiver was on the wrong side of the mountains. As you know, when you stand on the lookout at the top of the hill here, the planes come in below you, and so all of the plane tracks get cut off before they actually land in Wellington Bay. They did land okay. And that's just unfortunate because the data is not complete, but it gives you an idea of what the data could look like. And I can now start exploring this data initially in 3 dimensions. You can see there's some interesting patterns there. There tend to be some particular flight tracks from north to south, and this is where certain flight corridors exist. And then there's some low-lying traffic as well. You can see, for example, around here, there's some interesting flights. These may be helicopter flights, there may be tourist flights. There's a couple of flights out to the mountains out here. And you can see some interesting structure. I've actually learned quite a lot about airport operations by looking at some airports in this way. But of course, it is temporal data as well. So if I just go back to my slider here and just set this to my time column, I can spin through this data in a as fast or slow way as I like, so I can see what's going on, both temporally and spatially. And we think a little bit about exploring data in 4 dimensions so that you can understand what the temporal patterns are as well as the spatial patterns. And the nice thing about this is it's just spreadsheet data. The only difference between the earthquakes, for example, and the flight data is that the flight data has what we call an entity ID. There are planes that are recording their positions, and for a bunch of those positions, it's the same plane. And as long as I know what the plane ID is, I join the dots and turn those into lines. If, for example, I looked at these in a scatter plot, you could make some sense of it for closely packed data, but actually it's much, much harder to make sense of if you look at it in that way. So that was a demo of that product on a tablet PC. It actually works on any PC. And some of the things I wanted to highlight were this notion of when you work with tabular data and represent the rows as blocks in this way, you've got some opportunities to simplify how you visualize the data. You can just map the position, the size, and the color of these blocks to the columns in your spreadsheet. You can stack things up into histograms. It's a great way of explaining to people what a histogram is. Instead of doing a sum or a count, you actually just stack up the blocks, and the height of the column, providing the blocks are the same, tells you your count. And it's a nice way of helping people understand that. And you saw the way I can work with what I call entities, connecting these entities together with lines to build more revealing patterns in that way. I can interact, in this case, through touch, through pen, through speech as well, potentially. And these patterns that you find can reveal insight in the data. And then you can take those insights and you can play them back in a story, effectively. Those key insights that were found during the exploration phase took me maybe half an hour to find those insights in the tornadoes, but then I could play them back to other people and share the benefit of my knowledge. I could do that in person, or I could record a narration track and do that in an automated fashion. And you saw the way the blocks move, they transition, and it's kind of pretty, but actually it also builds a huge amount of context, and it lets people understand that the data they are looking at is related. If I actually go back to, let's go back to the earthquake data, for example, and look at this insight. If I turn off that animation, just make the time effectively 0 and jump between a couple of different insights. Am I looking at the same data? Am I looking at different data? I'm not really sure. I'm not convinced. Whereas if you do what we call a unit-based visualization such as this, where rows are always present, all rows are present all the time, you can flow those from one to the other, and you can do it fast, you can do it slow, you can do it any way you like. And you help convince the people that you're talking to that the data is the truth, which is important in our post-truth world. Okay. The nice thing as well is that it combines the storytelling with the exploration. So tools like this are important, and we've explored that with tools like World Wide Telescope and Power Map. You can use them for the exploration, but you can also use them for the storytelling. When you're telling the story, someone can say, but what about this? Have you looked at this? And you don't have to go back to the drawing board or say that you'll tell them in the next meeting. You can stop and pause the tour, do a live exploration, and then continue where you left off. And we feel that's an important aspect. So, alternate realities, something that I'm also interested in. There are a lot of terms around augmented reality, mixed reality, virtual reality. They mean different things to different people, so I just wanted to give you my take on what I think they mean. So augmented reality has been around, actually virtual reality has been around the longest. It's been around a long time. So let's start with virtual reality. Virtual reality, the column on the right, effectively replaces the real world. It shuts you off from reality, and it replaces it with another version, which is very immersive. You can't really get any more immersive than that, but you're in a completely different space. Let's hop back to the left of the table. So let's look at augmented reality. So this is a way of taking the real world, but not locking yourself away from it and augmenting it in some way. So holding a tablet or a phone and looking at a tag or an image, interpreting it, laying some data on top of that you can see typically on a screen is a way of augmenting the world. And then you've got this sort of middle ground, this what we call mixed reality. So it does augment the real world, but it is a way of being aware of what the world is in such a way that you can blend that reality with these, we call them holograms, but blend it with 3D visualizations that are layered onto the real world. And it is quite immersive because typically you wear a headset to explore a mixed reality environment. And I'll talk more about that in a minute. So now, you may have heard of HoloLens. HoloLens is one of the mixed reality offerings out there right now. It's available right now. There are others in the pipeline. I can play you a little video here for those of you that may not have seen it. This is a marketing video, so it's not really directly relevant to many of the things we're interested in, but it gives you an idea of what we think people might start using this for.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. new ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
So that was a little bit of a marketing video. I apologize for that, but it does give you a bit of a notion of some of the capabilities of the tool. So just to summarize, and apologies, I'm talking to you through a headset right now, but I can still see you, which is nice. It's a mixed reality device, which means that you're seeing the world. I can still see you while I'm wearing this device, but I can also see other stuff that I will share with you in a minute. It's untethered. Now, I am currently tethered, and the reason for that is because I want to share what I'm seeing. It's designed to be worn without any cables. It's a fully independent PC in here, but I am tethered for the purpose of just showing you what I'm seeing. It's aware of its surroundings. It can do depth mapping. It can understand its environments. You can place things on surfaces, etc. And you can interact with it using things like gaze. You can look at stuff. You can talk to it, and you can gesture using your hands. It also supports things like spatial audio, so you can hear the direction that audio is coming from, which is very important when you can work with effectively any direction of user interface. So what I wanted to do next was show you the same tool I just showed you earlier, but running on this device, and try and show you a little bit of the differences between the two. Now, one of the problems is that of using this device from a demo perspective is that it's really hard to show you what I'm seeing, because I'm seeing the world in a 3D way. You will see it flattened by video. But you still hopefully get some sense of what's going on. I would love to be able to say, just reach under your seats and pick up a HoloLens, because that's the best way, but unfortunately I could only bring one, and they still wanted to see it at immigration, at customs. But anyway, so let me switch over to here, and let's show you a view of what I am seeing. Now, this is going to be a little bit strange, because things like the micro head movements of my head, I don't notice that, but you will find the video very jarring. There's no real stabilization of my head going on here. And so I find this very smooth. And the frame rate is actually going to drop as well, because I'm sharing what I'm seeing. But we could just start by, let's take a little hologram here. Just for fun. Let's see if this works. So, is it going to play or not play? Oh, I'll come back to that. Okay, so let's go back to what I showed you before. So this is the tornado data set that I showed you before. And what I've done here is I've just put it on stage effectively. Now, what I would normally like to do is walk around it. And actually, unless I walk around it, you won't really get a sense of any form of depth parallax, so you can see what I'm actually seeing. But the nice thing about doing this is I don't have to learn how to navigate in 3D anymore. I learned how to walk a few years ago, so I can actually just move around. It's very intuitive to me to look at things from different directions, different angles, without having to learn how to do that using a mouse or a keyboard or touch. You'll also notice that I can actually, and I can't walk very far, unfortunately, because of this cable, but you'll notice that, let's actually get some more information about this thing. So all I had to do was look at an unusually bright cube over in the western portion of the United States. Now, you won't really see the text. I can see it a little bit more clearly. We have to halve the resolution so that I've got enough bandwidth to share what I'm seeing with you. But I would otherwise normally be able to read the text. So I only have to look at something to be able to get information on it, which is interesting. I can also interact with voice. I could issue voice commands if I wanted to, but I won't do that right now. And we could look at another data set here. So let's switch to a globe. And that's a big globe. So I'm going to push that out a little bit here and shrink that down. So let's just put a version of the Earth in front of me here. So this is worldwide earthquake data from NOAA, an organization in the United States. And normally I would just walk around this, but my cable isn't long enough, so my leash is keeping me by the lectern. So I'm just going to turn it round here. And you can see, and I can see it very, very clearly. It will be harder for you to make sense of this because you're seeing this in 2D. But I can see the layers of the fault lines that run up from the northern tip of New Zealand. And I can see how they sit underneath the Earth. That's very hard to do on a 2D screen. Interestingly, I also get a really good sense of scale. I can see that if I make the Earth about twice the size of a beach ball, because I can see the rest of the world, I know that the deepest earthquakes are about that deep. And I will remember that because I've seen it in this mixed reality fashion. So a sense of true scale, which is very, very hard to develop when you're looking at something that in a VR sense or just as a picture on the web, is something you really do get with this type of device. And we could look at those other data sets as well, just for comparison. So here we're looking at that earthquake information from 2016. You can see that I can start far more easily navigating around underneath the surface of New Zealand and picking out particular items with gaze if I wanted to. So from a data exploration and visualization perspective, it does offer certain opportunities that I think have been limited before. And I really want to start moving around this and looking at it from different angles. I wouldn't normally move it around with my hands. I would normally fix it in space and just walk around it. Okay. And just that final data set of the flight data. So here again, it's much easier for me to just walk up and have a look at what was going on here. Was this a training flight, for example? Maybe it was a training flight. Maybe that was a helicopter flight. I can see where the runway is for this airport just up the coast. I can see they made an interesting set of turns around the mountains there and came back. And I could play an animation that looked at these moving through time as well, so that I could see how they evolved, these flight paths evolved over time if I wanted to as well. But it's a fun way of exploring data that is a very visceral experience that you don't otherwise get when you're looking at a flat screen. And I apologize that you can't experience this in 3D right now, but clearly I'm around for a couple of days and I have a device, so come and find me if you want to have a look. Okay, so I'm going to finish that and stop the preview. Go back to my deck. So there are some benefits. You get depth, you get gaze. I know what someone's looking at, so I can track what someone's looking at, and I can show them additional information if they dwell on something, for example. The user is the camera. So this is this notion that you don't have to learn how to control complex three-dimensional scenes anymore. You just walk around it. You walk around the world as you would otherwise walk around the world. And you can use speech. You can use other forms of natural user interaction. You can talk to the device. And it puts things in context of a real world. So scale is one of those important things. And mixed reality means a lot of things to different people. But one of the benefits, other than knowing where the walls are and the floor are for your visualizations, is that you can actually just walk around and not bump into things because you can see the real world. And you can explore things in a far easier way. Now, I wanted to point out something. I'm not trying to sell anything here because I don't work in that part of the organization, but I'm trying to explain what I feel is an industry trend right now. Now, we announced at an event in October in New York that we're partnering with several partners to develop low-cost mixed reality hardware that will be available at some point next year. So you would be able to get similar experiences to what I showed you using a HoloLens, but at about 1/10 of the cost. They're significantly cheaper events because those are tethered and they are going to be mass produced. We also announced some ways of, and this is possible today, it's just not really widely used, some ways of capturing 3D. Most of the announcements focused around the ability to more easily work with and capture and use 3D content. Now, this is not going to be the world's most high resolution scan of a fig, but with a very large number of people in a community scanning objects, it has the potential to start revolutionizing the way we work with three-dimensional content. Okay. Now, I actually changed the title of my talk from Insights Through Visualization of Data to just Insights from Data, because it's not just about looking at spreadsheets, for example. There's a lot of lots of other types of data about. One of them is audio data, spoken data. And there was something really interesting happened last month, and this is why I wanted to mention it. There's this figure called the word error rate. If any of you work in speech detection, you might have heard of this thing. And it basically is the percentage of mistakes that you make when you listen to audio and you transcribe it. Now, for the first time last month, it was announced that a team had equaled, it's somewhat of a loose number for where people sit, but they'd equaled the figure of people. So they now have a system that in many cases will exceed the ability of a human to transcribe spoken audio, which is pretty impressive, and it does so in a very, very reliable way. And this is really enabling a set of other technologies that have been in research for a long time to do language translation. And up until probably up until about last year, most of the ways that you did translation was through statistically analyzing text to work out what the next most likely word would be in a sentence. What we've found recently is that there is an alternative approach based on neural networks. These are so-called deep neural networks or deep learning that is far more reliable. And one of the reasons that speech to text, the quality of it remained largely unchanged for about 10 years was that it took that long for the research to work out that deep neural networks were really, really, really good at doing this. And the tools are now starting to switch to using these deep neural networks for doing language translation. And they are really, really good. Now, I mean, if we've got time, I could do a quick little demo here, but I don't know if anyone has used this tool, but let me try this. So this is you can just download this tool, and there are a number of tools that do this. And I've just, what should we pick? Should we translate into, let's translate into simplified Chinese, shall we? And let's do that with, I could type, but let's use the microphone. Good afternoon. It's a pleasure to be able to speak to you this afternoon. So it just thought I'd finished speaking before I had done, but you see, it's actually pretty easy to do, even with a mic on stage, which is often a problem for these sorts of things. And you can do this in almost real time now. So you can install this on your phone, and you can have a conversation with someone in a language you do not speak, which is, I think, just amazing, it's groundbreaking. And it's highly likely that, at least with major languages, the barrier to understanding will be significantly reduced over the next couple of years. Now, there's another video I wanted to show where, I think we have time. This is an older video, but it shows some of the work that we were doing with a couple of communities, one in the US, the Hmong community, and another group of Nepalese students at Kathmandu University. Now, let's play this video, because I think it's an interesting insight to how this technology can potentially be useful.
The day I heard languages were dying, I wondered what else was being killed. Millions of words mutilated, thousands of songs unsung, hundreds of stories untold. Which language, I pondered, would answer this? How long would it take for humanity to be human? The day I heard languages were dying, I didn't feel so alive myself.
Yeah, now he slide out. Okay.
More and more information is being made available on the web. So our goal really has been to develop Microsoft Translator Hub in such a way that it would be web accessible from anywhere in the world. This empowers communities and organizations that want to build custom translation models to really take control of it, to create, improve, even deploy the system without a translator service getting in the way. This sense of empowerment allows under-resourced communities in particular to preserve their language and their community and culture for generations to come.
So as Microsoft looks to provide support and services to governments and countries all over the world, we have to embrace and respect the local communities to create cultural opportunities, economic opportunities, and opportunities for individuals to communicate within their communities and communities all over the world in their language with their culture and history preserved. And Microsoft Translator Hub enables that opportunity for governments, for communities, and for citizens all over the world.
What we did is we ran a couple of workshops, and we did this in order to reach out specifically to language communities. One of them was with the Hmong in Fresno, and the other one was actually at Kathmandu University with the Nepali language. The Nepalese students that we interacted with at Kathmandu, well, many of them weren't even fluent in their own language, which was very surprising to discover, that they were more fluent in English than they were in their own native language.
I personally don't speak in Nepali fluently, and the project Microsoft Translator Hub is helping me improve my fluency, and I think it will also help in preserving the Nepali language.
The elders inside of the Hmong community were watching their culture slip away, one elder at a time.
If we don't do anything about it, the culture and the language of the Hmong is going to disappear in this country. But with projects such as this, it's going to be one of the very important steps that we can take to stop this from happening.
The project is very important to Hmong. First of all, there are many reasons. One of them, of course, that comes to my mind is that the language itself, the written language itself, is less than 60 years old. So that makes it very difficult for the Hmong people to actually preserve any type of culture or any type of written language. So the project not only allows the non-speakers of English to be able to access information that are in English, but also it allows the speakers to now network across countries.
This machine translation project, which will work on the Nepali English sphere, will help us share our culture, local tradition and rituals to the rest of the world.
How do we do more, preserve more languages and more cultures as we go forward? Today it's Nepali and Hmong, tomorrow it's the world.
Now that was an older video, but it gives you an idea of some of the things that we're thinking of doing with this technology. And this is clearly allowing translation both ways. It allows people to go out and have conversations with people that don't speak English to collect information. It allows people that don't speak English to have conversations with people about the culture, about their heritage, and in a way that helps people preserve a record of this language both in their community and digitally in the form of these neural networks. And I want to finish by talking a little bit about computer vision, just because it's a huge research topic within Microsoft Research. And again, this has seen tremendous leaps and bounds over the last few years, particularly with the advent of these deep neural networks. And so this was an interesting project that each year people try and test their algorithms for tagging images. And so here's a set of common images. It's about 120,000 images, and it gives you an idea of how these algorithms are starting to perform. So let's say we're interested in testing our algorithm for recognizing books. Now, so here, for example, you can see that this is just an image. These are a collection of images, and I can see that this particular algorithm has found a book there. This is just a case, so there's a lot of books in there. There's a dog in that picture, and there's a book as well. I'm not sure if the dog was reading the book, but and these are starting to get more complicated now. Okay, it's recognized the books on the shelf. It's recognized the mouse, the keyboard, the TV. And this is a long list, and there's it's recognized a bear and a book and a person and a bed and some form of remote control. Maybe there was a TV there as well. So you're starting to see now tremendous advances in how this is working. And what we're trying to do is publish a set of programming interfaces, APIs, and we've called them cognitive services. And these are available. These ones are live today. They are available to program against, and if you're interested in any of these things, I would encourage you to go here and start looking at the APIs, because they're pretty amazing. From a vision perspective, from a speech perspective, from a language perspective, they can start enabling people to do really quite impressive things without having to understand the AIs that have been built using these deep neural networks. So I thought I would throw a couple of images from the National Library at one of the examples of an app that's been built on these cognitive services APIs, and this was the Vision API. So I found this image back from the New Zealand Tourism Department, maybe around the 1940s, and so I threw that at captionbot.ai. It's just a web address you can go to and throw images at it. It's learning all the time. It's still getting better. And it said, I'm not really confident, but I think it's a herd of sheep standing on top of a mountain. Now, I think that's pretty amazing, actually, that a computer has said that. But anyway, and I didn't even tell it was New Zealand. But so I threw one more at it as well. And this one was interesting as well. I'm not really confident, but I think it's an old picture of a man sitting on a bench, and he seems meh. So, which is fairly accurate. I didn't get his hat, unfortunately, but we can detect emotion now as well. We can detect sentiment, and we can start leveraging this in interesting ways. Now, I'm out of time, but there were other projects that I was interested in talking about. And I can explore these more. I'll run through them in about 30 seconds to give you a bit of a taste of this smorgasbord. There was something called Touch Art Gallery that used billion pixel images to explore data in artwork in novel ways. There was Destination Mars, which is a HoloLens experience that uses information from the Curiosity rover in 3D. There's HoloTour that lets you immerse yourselves in environments where you blend 3D scans of artifacts with panoramic scenery and spatial sound, which is pretty amazing. You can download that today on HoloLens. This was crazy. This took 30,000 Tate collection images, ran them through the Cognitive Services Vision API, and then tries to match them with the feed from Reuters Pictures services in real time. So it will occasionally throw up some very interesting correlations with classic images and what's currently trending in the news, which is interesting. And there's some collaborations going on to do language preservation in partnership with the Australian Museum and the University of New South Wales as well. This was fun as well. This was an idea of getting a computer to paint the next Rembrandt, which was an interesting project, but it again used some vision APIs to help understand the key features of what Rembrandt did, and then an AI to help construct a new version in the style of, and use a very interesting 3D printer to layer the paint in 3 dimensions in a way that followed his style. So it was an interesting project. And there's some other projects that are starting to come on tap with HoloLens now. I saw this one just last week from the Dutch National Museum of Antiquities that were using HoloLens to show off some of their vast collection of artifacts that they just can't possibly show in a real model that they have of a tomb, but they're filling it with virtual artifacts, and you can walk around that physical model using a HoloLens and explore those. So I'm going to end there, and thank you for your attention, and I am going to be around for the rest of the conference, so if you have any other questions, feel free to come and find me. Thanks for your attention.
Thank you, Dave. We have this